Hey guys, I hope you're doing really well this week. You may remember that a while ago we did this video. Let's help a subscriber 01. Now in this video, without ever touching the laptop, we were able to talk the subscriber through fixing a short on the main power rail. So what I'm going to do is, since I have no content ready to go this week, I'm going to do a second one of these. So during the week I received an email and this is what it said. I have an issue with the title laptop in which I have the following. Plus 20 volts main power after the current sense resistor, 3.35 volt LDO which outputs plus 3 VL and plus VLP respectively. I do not see the same chip outputting the NM signal which turns on the EC, though I can see 3.3 volts is present around the EC. I've also checked the jumpers for the 3.3 and 5 volt always on power and found no voltage there. Neither is there a short on these. I am not sure what creates my always on power for my 3 and 5 volt, even though the LDO is outputting correctly, which it wasn't before I replaced it. Okay, so it's replaced it already. My suspicion is that it could likely be a dead EC, but I cannot confirm this. Any thoughts? I've attached screenshots of the chip on the schematic and what voltage I'm receiving in the inputs. So I think what we're going to do is I'll get the schematic for that and we'll run through the input section right up to this IC right here. We'll see what generates those voltages and see if we can all help this person to get their laptop back working again. I found a schematic for the motherboard, as you can see here, BDL50 LAD702P. I think it might be a slightly different revision, but I've checked the ICs on this and they seem to correspond with what was mentioned in the subscriber's email. So I think it's close enough that we can work with it. So let's go straight to the input section then. So the input section for this motherboard is an 8-pin connector and 1, 2, 3, 4, 5, 6, 7, 8. We've got 1 and 2 that are connected together, and that's our main 19 volt rail right here. I know the subscriber did say 20, but it's described here as plus 19. 3 and 4 are connected to ground. 5 is not connected at all. 6 seems to be an ID pin. As you'll see here, this signal is called ADP ID from here. And 7 and 8 are the charge LED and AC and LED. So the one we're interested in is pin 1 and 2. So let's follow it along. So as the 19 volts enters here, there's a protection diode and there's a couple of input capacitors right here and here, and it comes across these two inductors, PL1 and PL2, where it is renamed as plus 19 volt underscore V in. So we should have 19 volts here as well. So if we wanted to measure at that point, all we would need to do is place our black probe to a ground, put our multimeter in volts DC in the 20 volt range and just take a measurement from here, and we should be measuring 19 volts all the way along this point here. So let's find out where this goes and we'll follow it through into the schematic. I've searched through the schematic and I found that plus 19V underscore V in comes out right here. And as you can see, this configuration looks very familiar. So we've one MOSFET, we have a second MOSFET, and we have a current sense resistor. The gates of these two N-channel MOSFETs are controlled by our battery management IC. So that's a BQ24725A. So you can see here the AC drive. That pin number 4 comes up here. It's connected to both of the gates of these N-channel MOSFETs, and as you will see on previous videos, this is usually 24.5 or so to switch these MOSFETs on. So what we would expect to find here is we obviously have our 19 volts coming through here to 5, 6 and 7, 8, which are the drain pins of this MOSFET. We would expect to find that the gate pin of this should be about 24.5 volts or 25 volts. That turns this on and our 19 volts should come through to here. Similarly, we have our 19 volts coming onto our source pins here, that's 1, 2 and 3 of our second N-channel MOSFET. The gate pin here should be about 24.5, 25 volts to switch this on, and that then allows our 19 volts through to here, which is our current sense resistor. And we should be measuring 19 volts here, and then this becomes our main power rail. Now going back to my subscriber's email, he has stated plus 20 volt main power rail after the current sense resistor. So I assume that what he's talking about here is this one being the main current sense resistor and this being the main power rail. Now he's in 20 volts again. I'm just going to read that as being that the main voltage rail is online, be it 19 or 20 volts. So the next thing we need to track is to find out what chip is responsible for producing the 3.3 volts and 5 volts always on. So let's see if we can find that. Now, my subscriber mentioned that he considers RT8243AZQW as being the IC that he considers responsible for generating his 3.3 volts always on and his 5 volts always on power. Well, I've gone right back to the datasheet from the manufacturer to get a look and see what this IC does. What I find is really useful is if you find a typical application or sample circuit for one of these, it pretty much gives you how it should work in whatever circuit that you're using it as well. Most of these have a similar function no matter what circuit you drop them into. But this one here is taking a V in of 5.5 to 25 volts, which is fine. We have 19 or 20 volts coming in. That comes into our V in to power the IC. And it also goes to an enable pin, which I presume enables our LDOs. ENLDO, I presume, means enable our LDOs. Those LDOs are on pin 14 and pin 15. And as you can see, LDO 5 on pin 14 gives us our 5 volts always on power. LDO 3 on pin 15 gives us our 3.3 volts always on power. There's two switched outputs, so we V out here, which is a higher current 3.3 volts, and we V out 1 here, which is a higher current 5 volts. But these two, this 5 volt here, V out 1 and V out 2, should only be present when the laptop is powered on. What we need to check at this stage is to make sure that we are getting power on V in on pin 11, and that we have 5 volts on pin 14, which is our always on 5 volts, and 3.3 volts on pin 15, which is our 3.3 volts always on. So now that we have a brief overview as to how this IC works, let's see how it fits into our actual laptop schematic. Well, this is it here, and you can see we have V in. Our main 19 volt power rail is coming in, and onto that it's coming through a resistor and onto our ENLDO also. So he said that his 19 volts or 20 volts is online, so this should be fine and we should be getting an input. So the question is, what outputs should he be getting? With the laptop powered off, should there be any outputs on this IC? Well, yes, there should, because as we've confirmed, pin 14 should have 5 volts always on power here, even when the laptop is switched off, and pin 15 should have LDO3, which is our 3.3 volts always on, which should also be present even when the laptop is powered off. I think what's adding confusion to this is that if you look at the two switched outputs, they are referred to as plus 5V ALWP and plus 3V ALWP. So the assumption one might make is that ALWP is always on power and plus 3V ALWP is always on power. I don't know why they would label them like that. It's just a recipe for confusion, I would have thought. But like I said, the only thing that needs to be available on this before you power on the laptop is our two always on powers right here. So with confirmation that pins 14 and 15 were the pins of interest at this point, I asked him to introduce his multimeter in voltage mode, DC, place a black probe to ground and just take the two measurements. First of all of pin 14, and he measured 5.5 volts at this point, and then pin 15 and he measured 3.3 volts at this point. So we could be sure that there was confirmation that the two always on voltages were present and that this IC was doing its job. So the next thing to check was the power button. Further down the schematic we managed to locate the circuit for the power button. So this is a connector on the motherboard, so there's only 4 pins on it. It's one of the easier ones to work with. So how do we check it? Well, we introduce our multimeter in volts DC, place a black probe to ground, and then place the red probe on the pin that we suspect is the one for the power button. Now it's marked on off here, so it's quite easy to see. So what we should be expecting is I place my red probe to this pin number 3 and I should see 3.3 volts on it. Now I leave my multimeter connected to those pins, and what I should see is when I press the power button, my reading should go to 0 volts, and then when I release the power button again, it should go back up to 3.3 volts. I asked my subscriber to do that, and he confirmed that that was working as expected. So the next thing to check was just to make sure that that on-off signal was making it back to our Super I/O. Just to be comprehensive, I located where that on-off signal from the power button comes back down to the Super I/O, which is here, as you can see, on/off hash, and this shows me that it's an input and it's coming in on pin 114. So I asked my subscriber to check here while pressing the power button, and it was receiving the signal from the power button. So when we press the power button, it would go to 0, and release the power button again, it goes back to 3.3 volts. So this is the current status of the laptop. Our main 19 volt power rail is working. Our 3.3 volts and 5 volts always on power are also working. We have 3.3 volts at the V-in pins of the Super I/O and at pin 8 of the BIOS IC. We have 3.3 volts on the power button, and when I press down the power button, that 3.3 volts goes to 0, and when I then release the power button, it goes from 0 back to 3.3 volts. So the power button is also working. And I've just confirmed on pin 114 of the Super I/O that it is receiving the on-off signal from the power button. Just in addition to that, we have confirmed that there's no shorts measured at any of the inductors. We have no visual signs of any problems on the motherboard, and there is no excess current being drawn in standby mode. So now what options are available to us to try and resolve this problem? Well, the first thing we could try and do is to step through the Super I/O triggering process. We know that the Super I/O is getting input voltage and it's receiving the power on signal, but it's not coming on. So there is an actual triggering step by step that some YouTube channels have put together. If you take the Dhaka Lab and Institute, for example, by Fahim Arman, you'll see this video in the description. I've linked to it below. He has a little diagram here of the I/O trigger stage. So he goes through step by step what should happen in order for a successful Super I/O power up. So it's basically the first stage is you need to check for an input voltage. There also should be an analog voltage, there should be a ground, there should be a pull-up resistor connected to another pin that has 3.3 volts LDO also. There is a Hall switch or a lid switch to check to make sure that the lid switch, that the lid isn't closed. There is thermal protection here through a resistor ladder. There is a crystal that needs to be working in order to give it a clocking system, number 7. Number 8, the lid switch out signal needs to be sent from the Super I/O to the PCH. The power button, which we've just checked, needs to be working, and that power signal then needs to be sent on to ICH PCH. Stage 11 is where it communicates with the BIOS, and if all of those steps work fine, then you will get an RSM reset from the Super I/O to the PCH. Again, just to give credit to Dhaka Lab and Institute, and there's a link for this video in the description below. Now, what seems to happen is most of the electronics websites that I look at don't seem to bother with going through a step-by-step of the Super I/O. At this point in the troubleshooting, most of them just seem to start swapping and reprogramming parts. So they would probably reprogram the BIOS first because that's the easiest thing to do, and maybe replace the BIOS IC. And then if that doesn't work, some of them will replace the Super I/O, which is not easy, and then some of them require programming as well. So you now need a programmer for a Super I/O chip as well. So that's what I would be suggesting, but what I'm interested in is what would you guys suggest, because I'm always willing to learn here as well. And if I've got any step wrong here, or there's something better maybe that could be done at this point, please put in the comments down below, because what I want to try and do is use the force of my 1, 2, 3, 7 subscribers at this stage and see if we can help get this laptop working again. So that's where I'm going to leave it for this week, guys. It's over to you for your comments. But wouldn't it be amazing if we could actually get this back up without ever seeing the motherboard? That would be something. Just with regard to the channel, I've got a number of motherboards that I bought at the weekend. I paid quite a bit of money for them. The guy looked at me like I think he's lost my mind because I'm paying him all this money for a load of broken motherboards. But at least it should give me some content for the channel. And I will have a look at those this week and hopefully have some content up by next weekend. But make sure and get your comments down below, and I'll talk to you next week. Thanks.